Hey, my name is Spencer. I'm one of the founders here at Build Better. Now, this is a course that's going to go over a lot of stuff around how do you use AI in product. You don't necessarily have to use Build Better for this. We're not going to use Build Better for all of this, but it's going to help you kind of get from a 0 to 1. What is product management with AI? How might it change? What does the future look like? What can you do today? And some really kind of advanced ways of using AI today that might really progress you and your ability to prototype and work with your team, and also just get your team up to speed with AI. Now, my background, I was former head of product at a few Series A, Series B tech companies in the Bay Area. I've been obsessed with product. My background was actually traditionally trained in user experience research. So that was kind of our first start in AI ourselves. Back in 2020, we were one of the first tools to actually launch with some GPT powered kind of B2B applications. And that was really focused on, well, how do we help product managers synthesize and get information from the user research calls that are happening, whether it's from them or for someone else. So we launched that in 2020, and every year we, started getting early access to some of these models. We started to see the progression. We saw how they were thinking, how they were working, and that really helped us build the best product for product teams. So, I'm going to share some of the things that our customers have come to us and said, "How do I do this? How do I train? How do I think about AI? Is it going to take my job? Is it not going to take my job? What are some of the applications that I can use today? What might be changing?" And we'll kind of try to keep this as up to date as possible as things develop, but some of it will stay true likely for, a couple of years. So we're going to kind of go through a lot of that information, but just to start off, we're going to kind of go through the high level. So what is ML versus AI? What are some kind of core mechanics that maybe understanding will help you understand why I'm going to be suggesting doing X instead of Z? We're going to go over high level kind of prompt engineering. We're going to dive a lot into prompt engineering a little bit later. And then we'll go over some privacy concerns, ethical concerns, kind of some popular tools that you've probably heard of and what's the difference between them, some foundational model stuff. We'll talk a little bit about AGI. Impacts on your job, some key takeaways. So that will kind of be the core of this specific first session itself to kind of see if this is the right thing for you. So to start off, traditional ML versus kind of generative AI. Now, the number one thing to learn here is that there is not a tremendous amount of difference between what we consider this like super, super crazy powerful AI and some of the machine learning stuff that we had a few years ago. The real big difference is, the knowledge it's trained on, the size of the knowledge it's trained on, or the parameters that it has, the weights that it has inside of those models. And we'll kind of go through a lot of that. But I think a lot of people have this misconception that we've it created this crazy innovation over the last 3 years that just completely changed everything. The reality is that the underlying technology has been a technology we've been using in ML for a very long time. In relative years, in ML and in software years, a fairly long time. So, I'm going to talk a little bit about what this is. And I think it's really important for you to understand that, because when you start using these models, a lot of people start looking at them and they think they can all of a sudden accomplish anything with AI. And you'll start hitting these, roadblocks and these walls really, really quickly. And you'll be like, why can't it do this thing? It's so good at this other thing, but it can't do this simple task that I'm asking it to do. And this will hopefully help you understand why. So to start off, kind of core things, we have these things called tokens. Now, tokens are effectively just a random number. So you can think of them as like 1, 2, 3, 4, 5. And this token, let's just say this is the word the. And basically, the way that everything is kind of done in ML, it's all kind of math based. It's really, really intense math. It's matrices. And basically what these MLs are doing, or what these AIs, what these ML or AIs are doing, these LLMs, all of these are going to kind of be interchangeable. It's all kind of fundamentally ML. We use AI as just kind of like a stepping stone of like, hey, this is so good, we're going to call it artificial intelligence. But we've been calling ML AI for the last 10 years, and we'll continue to call a lot of ML AI. But LLMs, AI, ML, all interchangeable in this conversation. So every kind of word that you can imagine has a specific number associated to it. So let's just in theory say is 1, 2, 3, 4, 5. Now, the job for these AI systems to do is to predict what's after this number. Now, if we were to make this even simpler, let's say the word the was 1, and let's say the word apple was 2. The question I would have to you is, well, what comes after 1, 2? And the obvious answer is 3. Now, let's say 3 was doesn't, and now we have 1, 2, 3. Now, you and many of you might know what's coming next because you've seen this before. You know the apple doesn't fall far from the tree. So if I were to say, well, how quickly or how well can you predict the next word? You might have a lot of people who might suggest other types of words, like let's say the apple doesn't eat, the apple doesn't rot, the apple doesn't turn, the apple doesn't. There might be a lot of potential words that might come next, but there will be consensus. If I were to ask 100 people, that fall is probably going to be the next word. So the job of ML and the job of AI is to say, okay, here's all the possible options that we might be able to go to. We might be able to go to fall, we might be able to go to rot, but we have a confidence that this thing is going to go to here instead of here. And that's it. That's as much as you really need to kind of understand. So here's kind of an example that will be good. And this one doesn't use the tokens or the text that it's being used under it. But you'll see here that it's just predicting the next word. So what are some of the downsides of predicting? Well, the downside of predicting is that it actually isn't good at coming up with something genuinely new. It can only really come up with something that it's kind of sort of seen before. So back in the old days, 3-4 years ago, when kind of this AI was still in its infancy, and we had GPT-3 presented by OpenAI, you'd have to give it a lot of examples before you asked it to do anything. So you'd give it some example. You'd say something like, okay, this was like some feedback that maybe we would got. We'd say the feedback was, your product is awesome. And then the category would be, let's say, positive. And the sentiment would be happy. I'm kind of going on the fly here. Category and sentiment might be different. And then, let's just say that was it. And so what we would do is we'd kind of create a lot of different examples where we kind of change the text, 3 or 4 or 5 different times. Now, traditional ML, it wouldn't just be 3 or 4 or 5 different times. It'd be thousands of times, hundreds of thousands of times. And we would basically be creating a foundational model or a model just for this specific task. And so that's kind of like what ML used to be. So ML used to be this kind of, I need you to do this one task, and I'm going to give you a ton of data to accomplish this one task. And then I need you to basically on Adam, just keep repeating doing this task as many times as you possibly can and as fast as you can. But it could only do that one task. If you all of a sudden went from feedback to something else, like let's say it had never recognized action items before. It only categorized feedback and never categorized action items. The model would just completely break. It would have no idea what to do with that. So these AI models, they kind of started these massive foundational models where it was trained on a ton of corpus of data, nothing specific. It wasn't trained on just feedback categorization or just X or just Y or just Z. It was trained on really everything. And you can fine tune those models where you could say, hey, I know you're trained on everything, but I want you to actually be really good at just this one thing. Just categorizing feedback or whatever it might be. And fine tuning is really good when you have a really, really domain specific task. Like let's say you had a specific language of code that the model wasn't traditionally trained in, or maybe a library got updated in your code base or something like that. And you might want to say, okay, well, a lot of people use this R AI tool for generating code in our language. So I want to fine tune it on generating code in our language. That would be like a traditional kind of example for fine tuning. But the vast majority of stuff that you need to do, you just kind of do this prompting. Now, in theory, this was kind of what we were doing early on with GPT-3. We were kind of doing this prompting where you'd kind of give it an example and you kind of fill it out. And then on this last one, what you would do is you do this. You kind of leave it the thing empty. So you say, here is your feedback. You tell me what the category is. You tell me what the sentiment was. And it would do that prediction. It would say, well, I know after category comes one of these words. And I know after one of these words comes sentiment. And I know after sentiment comes another one of these words. And so, it would kind of make an assumption about, well, given what has already been given to me, there's probably going to be something next. Nothing has changed from this way of thinking. This is the same models, just ramped up and larger. So when we think about how we use these tools, we have to remember that these are prediction machines. They are going to be good at predicting the next word. We cannot expect it to know things that it doesn't already know. We can't expect it to be particularly creative. We can't expect it to figure something out that's never been figured out before. So a lot of these things, it's getting very smart, but what we mean by smart is it's very, very good at understanding what we want it to predict for the next word. That's what we mean by, like, it's so much smarter than the previous generation, or it's so much faster, or whatever it might be. Is it's faster at predicting that next word, and it's better at guessing what that next word might be. And a lot of this has to do with how we prompt these systems. So let's kind of go into prompt engineering. So this was kind of rudimentary prompt engineering, a few years ago. You kind of give it some examples. Now prompt engineering, you probably have seen, looks something more like this. Pretend you're Albert Einstein. Terrible at spelling. Hopefully I got this right. Pretend you're Albert Einstein. Think through this problem with rigor. So prompt engineering might look something like this. Usually the quintessential prompts that you'll see have some kind of like pretend like you're A. And the reason why we often think about pretend like you're A is how these neural networks, which we don't have to dive into, kind of are set up. So I'm going to quickly kind of go over this again. Please talk to a ML AI researcher if you really want to dive into a lot. I'm genuinely giving a super high level just because I think it's important to understand these concepts when you're starting to do this stuff. But you do not need to be an expert in this to understand how to do prompt engineering. But hopefully these explanations do help. So these kind of word predictions, they're built into these neural networks. And these neural networks are basically little clusters of, let's say, information. Like kind of clusters of tokens, but like, let's say they're clusters of information. And so when we say pretend to be Albert Einstein, we have these massive foundational models. Remember, foundational models are trained on all of this random data, And so they can answer a lot of different types of things. So when we prompt it, when we're asking a question towards it, what ends up happening is we're telling the model where to focus its knowledge. So we might say, okay, hey, Albert Einstein knowledge is right over here. So let's just focus our knowledge on what that information looks like, what those predictions look like. Because what you don't want to have happen is that when you're doing these predictions, when you're looking at fall or rot, it's pulling from, well, rot is over here and fall is over here. So which one should I prioritize? Which one has the best ability to predict the next word? Well, for your given use case, it might mess up. It might say rot might be the best example because you told me to use words that were nasty, and nasty words are rot. So it's going to predict that rot would be the next word. But if you said, I want you to be an Albert Einstein, I want you to be really clever, I want you to be really smart, I want you to predict what would be the most likely word to come after doesn't in an American language or in an American view or whatever it might be, you might say, well, a lot of the saying is often the apple doesn't fall far from the tree. So it's probably going to be fall. So by using these kind of pretend like you're blah, 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 or pretend like blah, 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 it's an easy way for us to communicate to the model, this is where I want you to focus your knowledge on. This is what I want you to think through. So that in general is kind of why we do some of these newer versions of prompt engineering, which is kind of like pretend like you're a writing assistant, pretend like you're, working on the world's most difficult problems and you have to pretend like you understand these things. It's really just to help the neural network understand, where should I focus my knowledge on? Now you can see that the more you kind of give to it as context and the more focus you can kind of allow it, the better results you'll tend to see. So if I were instead to say, pretend like you're Rob Fitzpatrick, and there might be a few Rob Fitzpatrick, so I might want to clarify who wrote the mom test. And I want you to come up with new questions for a research project. And then I might go on and kind of give it some examples of what I wanted to do. But what I'm doing here is I'm trying to say, I need you to focus on knowledge and think through a problem that Rob Fitzpatrick, the prediction model would be that Rob Fitzpatrick would basically predict. So what would be kind of the words and language and tone and thoughts that he might have on stuff. And I want you to make sure that it's the right Rob Fitzpatrick. I don't want you to do Rob Fitzpatrick that maybe invented something 100 years ago. I want you to do the one that wrote the mom test. And I want you to also focus on user research and questions. So maybe the model's trained on a lot of that stuff, and I want you to focus on that information. And then from here, I might give it some data, some example of data, and then I might kind of give it the specific question I have. So, here's what I want you to do. So that in general is kind of how these prompts generally work. Now this is changing, and we'll talk a little bit about how these prompts have kind of changed over time. They're definitely becoming more concise and more clear, and there's a reason for that. But that's the general gist of kind of what prompt engineering is. Now let's kind of dive into, we've talked about these models. There's kind of a few of them. We've heard about kind of closed source models and open source models, which models should you be using this prompt engineering on. You've probably heard of OpenAI, which is probably the largest model provider today. But there's also Anthropic that comes out with Claude. Google has, this is an old one. It's not called BERT anymore. It's called Gemini. And you have other models that have kind of come out from open source to closed source. Now, what is open and what is closed? You can kind of think of closed source models and open source models similar to like a train that's owned by a city versus a car that you get to own yourself. Now, closed source models are often much larger. They run on much larger infrastructure, similar to a train, and they allow you to do something you could never do in a car. Right? Maybe you could transport thousands of pieces of furniture from one place to another. Maybe it gets you to a place much cheaper than you could do if you were to drive in your car. But there are limitations. You don't own the train. The train doesn't go where you want it to go. There's a lot of specific things around trains where, yes, it might be cheaper in the short run, but it might be more expensive in the long run. Let's say if you had a trucking company and you wanted to get stuff from point A to point B, it might be cheaper to just have your own system, your own trucks, your own cars, stuff like that. So that's kind of like the high level of some of these closed source and open source models. But one example of that is some of these closed source models are run by OpenAI, by Anthropic, by these big companies, and they cost a ton of money just to boot up, just to kind of get going. And so these models themselves, a lot of people might prefer to have their own model on their own infrastructure for data reasons, for privacy reasons, for security reasons, where no one else can touch that. It's their model, it's running on their own data, it's doing their own stuff. But it also might be better for that fine tuning. So what I mentioned about this fine tuning is that you can kind of take a model and you can say, I want you to specialize on image generation. Or I want you to specialize on, I need you to be incredibly fast at labeling feedback. So I need you to just do feedback. And some of these open source models are much easier to train on. They have a lot more capabilities. You can kind of manipulate and turn them into whatever you want them to be. And so there's a lot of use cases where these open source models can be much, much, much better at specific tasks than these closed source models, because these open source models, while sometimes trained on a closed source model, these massive models, they're often much better at specific tasks. So you'll see when these open source models come out, they're smaller, they run faster. Sometimes they run on your device, like you could run one on your own device, but they're often only really good at specific things. So maybe they're good at just having a chat conversation, but they're going to be bad at generating code. Or they're going to be good at talking about coding, but they're going to be really bad at writing documentation. So that's kind of some high level of kind of closed source and open source models, which also kind of dives into, well, what about AGI? Once AGI comes out, isn't that going to change everything? Once AGI comes out, isn't my job gone? And we'll talk about the future of AI with product management. But I think what we need to understand is we're in this territory still. We're in prediction territory. And when you think about AGI, it needs to be a little bit better at predictions. So the first step is what we call agents and what have been coming out as agents. And what agents do is they basically, they're no different than any of this prediction stuff. But instead of stopping at, okay, here's the category, here's the sentiment, okay, stop. I want you to stop when you have this. Instead, what it does is it has multiple LLMs, and they kind of all look at each other and they kind of run in sequence. And, this LLM, I'll just kind of delete this and say, LLM, LLM2. So what agents basically are is it's saying, well, this guy, it's going to come out with a response. So let's say I wanted to write a document, or I wanted to do a research project for me. And then when that response is done, this LLM is going to look at this response and it's going to give it feedback and critique. So it's just kind of runs in this loop. And sometimes there's multiple, sometimes it's 5 or 6 of these loops or whatever it might be, and it'll kind of like run in this thing. But at some point, one of these models and one of these prompts is going to check the final answer, and it's going to decide, okay, is this response, are we done? Are we done now? So a lot of this agentic stuff that you're seeing, these agents, they feel much smarter, they feel much better because they're really kind of just reflecting. They're going back and they're saying, hey, I got an okay response the first time. I want you to double check that. Is that the right response? Should I change this? And then something else is like, well, let's think about this another way. Maybe we should approach it from this way. And then these two are talking back to each other. And then this one goes back to the first one and says, hey, I want you to rewrite that, but here are the edits and changes. And then this one sends it back to number 2, and then number 2 sends it back to number 3. And then after a few of these things, number 4 goes and checks and says, hey, you're done. You're done. We're done. This is good. This is good enough. Let's move forward. Let's progress. So those are that high level. It's kind of what an agent is. And this can feel like AGI. This can feel like artificial general intelligence that can answer anything and do anything for you because it's a lot more autonomous. You're not kind of fighting back and forth. It's giving you better answers on the first try. And there's a lot of stuff. I mean, we at Build Better, we have a lot of agents inside of our tool itself. But from a high level, we're still in this prediction camp. We're still predicting the next thing. We just have a lot more steps on top of it. And so when we think about AGI, we're thinking about, okay, what does general intelligence look like? Let's say it will, the first version will probably be like Tom from accounting, is kind of how we think about it. It's going to be basically a person that could answer a general question. Like you could ask it, hey, what's the best food in California? And instead of just stopping at, the best food in California is, the French Laundry, or something specific like that. Is it French Laundry, French Pantry? I think it's French Laundry. The French Laundry, it will come back and say, hey, well, depending on kind of how you're thinking about this, there could be a few categories, but what are you looking for? What are some kind of specific things? And you're going to have a conversation with it. And it's like, hey, well, I know that your dietary restrictions kind of talk about this because I pulled back from some other information. And, I think that the best option for you would be something like this. And you can kind of keep having a conversation with it and it won't kind of get silly all of a sudden. And you'll just be able to keep diving in and you'll have access to the internet and you'll have access to all these things. And that will generally probably at that point kind of feel like AGI. But we're not going to, there's not, at least in the pipeline today, there's not a huge innovation that's kind of around the corner that's going to change the whole game again. So when we think about AGI and when we think about stuff, my best example about are you afraid of your job is the Albert Einstein example. The Albert Einstein example is something I give to a lot of our investors and a lot of our customers and people who are just generally afraid of AGI, which is, let's say we have this insanely high IQ person. Let's take Albert Einstein, quoted to be one of the smartest men to ever live, and let's have him write a PRD. So if we were to take Albert Einstein and we were to say, hey, Albert, I don't know if he would go by Bert or Al, but hey, Albert, I want you to write a PRD for my company. And I want you to write that PRD about a search bar that we're adding. Now, if Albert tried to write a PRD about a search bar, how good do you think he would be at writing that? He could probably give you a structure. He probably has some general understanding about what search is and what the problem a customer might be for search and stuff like that. But it's not going to be as good as a random person. Can we have a sticker for a person? Yeah, perfect. A random person at your company who understands who your customers are, you understands the tech stack, the engineering scoping, the priorities at your company, what has been tried before, what hasn't been tried before, maybe the jobs to be done. Maybe they've already looked at feedback from customers. They know what the problems with the existing search bar is. Maybe they even know that there is a search bar. Like all of these things, that context matters a lot more than the intelligence. It doesn't matter how smart you are if you don't have the context to answer a question well. And this is really like the age of context. It doesn't matter how smart these systems go. If they do not have the context, it's going to be difficult for that job to be replaced with AI. Now, the good news for AI is that we're getting really good at building context for AI. Now, with a tool like Build Better, we could give the AI that context. We could say, hey, here's all the customer data related to search feedback. Here's all the internal meetings related to talking about search. So now Albert Einstein is still Albert Einstein, but now he has all this context that maybe even the person inside of your company doesn't have. And now this could be way better than this because they have more context, better context, and they're still Albert Einstein. So there's some fears when we think about it, but it's not going to be one of those things that like switch flips on and all of a sudden it can solve all of the world's problems. It's more about switch turns on and now we can give Albert Einstein this context and it can do as good of a job as a person or sometimes better. So when we think about AGI, we should be fearful in some places, but oftentimes really high context scenarios where we have to know years and years of information and company history and all this kind of stuff and, people and dealing with people and priorities and the customer market and all this stuff as the market kind of gets unfrilled and all this kind of stuff, we actually might see more product people becoming much, much better at kind of running companies and thinking about long-term vision and strategy and have a harder time for AI to compete with than something like engineering, where all the documentation is online about how to write something or do something. And a lot of products are CRUD apps. They're just kind of built on top of the same infrastructure, the same pipelines, the same UI components. And it's really just delivering, the end result where there's a lot more predictability. So that's why AI has become very, very, very good at coding and not quite good at writing PRDs yet. Because the context needed to write PRDs is very, very, very different than the context needed for coding, because they already have all the context they need for coding. So that's kind of a high level of kind of AGI. You can expect AI to get really good at operational work at your company, thinking about operational work, doing the work that is highly repetitive, fairly low context, but needs a little bit of context about you, your product, your companies. And you'll kind of see stuff like that over the next few years. It just gets better at consuming context, finding context, and doing operational work. I don't think we're going to have AI that's particularly good at planning. From a product strategy standpoint. I don't think we're going to have AI that's particularly good at strategy or particularly good at stakeholder management. That often relies a lot on very, very heavy context and a lot of knowledge, and it's going to be really hard for AI to do that. So key takeaways here, AI is really good at prediction. That's its bread and butter is predicting. It's limited in a lot of ways. It has a lot of bias. One of the big bias things for it is because it's a prediction model. It is mostly biased towards positivity. And we'll talk a little bit about that on some of these prompts. But, if you were to ask it, what do you think of this idea? 9 times, maybe even 10 times out of 10, it's going to say it's a good idea. It likes that idea. It thinks it's a positive idea. That's because it's been trained on what people like hearing. And what people like hearing are positive news. They like hearing positive things. So there's a lot of inherent bias in a lot of AI. It's also obviously trained on only the data it has, but the biggest bias you'll see is the bias towards positivity. These models are also, becoming more agentic. So they're kind of looping on one another and they're saying, hey, I want you to double check this. I want you to make sure that this is working. We talked a little bit about prompt engineering, how it focuses that knowledge on specific areas of its knowledge graph. So it can answer questions with much better accuracy. It can understand what that next word might look like. And we've talked a little bit about AGI, how it might take some operational work off the table for teams, but it might be kind of bad at some high-level thinking, creativity, lacking prediction and more kind of thinking outside the box. Thinking about something that hasn't been done before at our company or in the world before. So that at a high level is kind of what AI is about, what we're going to dive into. The next classes, the next conversations, we're going to go over really kind of like use cases. So we'll kind of go through some real world use cases for AI and product management, and we'll go from there. So thank you so much. And hopefully you'll finish this course. You'll get your certificate. You'll get your badge. You'll be able to show off to all your friends. And we will talk to you very soon. Bye.